So we'll look at one more example, which is directly relevant for assignment 12. And this is on page, I didn't write the page, page number 353, example 24. And on the next page, you can sort of see how this example is solved. And it just says solve using technology without going into details. So I'll go into the details now, and we'll see how we can sort out the B question here. Now, A is we don't worry about A here, so it's the B question, where you have a study that shows that 0.9% of the population of over 4 million carries the virus. Find the smallest sample from the population so that the probability of the sample having no carriers is less than 0.4. So our random variable here is, we're going to call that V. That's V for virus carriers. And the probability for each person in this population carrying the virus is 0.9%. And we need to translate that into a decimal number. So 0.9% is the same as 0.009. So that's our P here. And we're asked to find the smallest sample, the number of trials. So the number of trials, that's our unknown here. So we don't know the N. And that's what is different about this example here. We don't know N. So when we model this as a binomial probability distribution, we have that our variable V is binomially distributed with the parameters N and 0.009. And furthermore, we know that we know the probability, so that's not what we want to find. So we know that the probability needs to be less than 0.4, yeah, or 40%. So the probability that the number of carriers is equal to 0 should be less than 40% or 0.4. And what we want to find is this N here. Now, you'd think that you could use the calculator directly here and use the inverse binomial function. And we're going to look at that and see how that's going to work out. So here's our calculator. And if we go into, well, that's the, okay, main menu and 2 for statistics, distribution F5, and binomial distribution. Oh, yeah, and actually on this emulator, there is no option for the inverse binomial function, but you have this on your Casio calculator yourself. So if you look at the option you have there, you'll find that it says as the third option INVB, and that's the inverse binomial. Now, if you press that, and if you decide that the area is going to be 0.4, so that's the probability that you know already. The number of trials, if you try to set that as an unknown or X, and the probability at 0.009, you won't really get an answer to the question. And that's a bit of a problem here. The calculator is not going to deal with this if the number of trials is set to unknown. So you have to define the number of trials here. So there must be a different route that we can take, and we're going to have a look at how we would do this by hand. So we have to use the formula here.